clone. Let me fix that on Slack. Thanks. Let's go. Good morning. Welcome to what we traditionally call the Authentication Week. It's more about, securing your APIs, and traditionally, this goes through a couple of projects. So what's going to happen is we're going to have 4 lectures. One is an introduction, that's for today. And this is the theory part that we get out of the way, right? And then we move into using something called sessions and cookies as part of the authentication workflow. And then after that, we move to replacing the sessions and cookies with something called JSON Web Tokens. And all of this is happening on the server. Then after that, on the 4th day, we normally do client-side authentication, meaning what do I do with those tokens once I am on a React application on the front end. And then, of course, you have your sprint challenge. That's the traditional way of going about this week. Now, I have a proposition. I talked about this with your PMs. And I would like to have a vote on this. And the answer would be if you want to try something, yes or no. Okay. Gonna make this anonymous so you don't have to say why, just answer. Let's try it out. You don't know what it is yet, but I'm gonna tell you. And the idea here is if you go back, people are saying yes without knowing what it is. So the idea is if you go back and watch the videos, probably some of you did, you'll see me stressing the idea of there are people that make a lot of money working security. Do not roll your own authentication system unless you really have to for some reason. Always go with a third-party solution for this. So we keep saying this the whole week, like making sure we're going to show you how it's done, but please, if you can get away from that, don't implement your own. So what we want to try this week is see if we can compress the 4 lectures into 2 or 3 days so that I can actually introduce an alternative to roll your own, right? And the alternative is using social media authentication with something like Google. And then, of course, you can expand that to use other social media or other companies like GitHub or maybe Twitter or Instagram, Facebook. But we'll probably just take a quick look at Google just because it's easier to set up. They don't have you jump into too many hoops, right, when configuring your third-party authentication. I have a no. I have 6 no's, which means that's probably not a good idea. So what we're going to do is instead, we're going to go through the traditional week. And then if anybody else is interested, and then probably we'll do some extra stuff later. Because we're not going to just, as long as we have one person not willing to go, because that would mean you going through the content faster and devoting more time to reading what's there on Training Kit and probably rewatching some of the prior lectures if you still want to learn how to roll your own completely from scratch. So I guess what we may do is I'll just change that and leave it for the next cohort then. This is why these polls are important, because we thought it would be a good idea between us, but apparently we have people not willing to give that a try. Cool. All right. So in that case then, here's what we're going to do. We're going to start working on the first day, like we always do. The introduction is important. And then we're going to move on to working with sessions, and let's see how much we can get done. But there is no requirement that you finish the project and that used to be 2 days, today, right? So this first project, you could still take 2 days for it. If everybody happens to be done by tomorrow, then we'll continue to the next. So instead of going linearly where we cover this Monday and Tuesday, and then Wednesday and Thursday, we may or may not have time left at the end instead. Okay, this is why anonymous votes are important. We have 4 people not that don't want to try that. All right, so let's start with the lecture for today. I'm going to be working on this Auth Mini project right here. And as I implement some of these things here, you will notice that the requirements that you have to implement in the project are the same. So instead of having you follow along with me on the Mini and then having to copy that code later in the project, I'm trying something different. I'm going to have you start working on your authentication project with me in the morning, and then we're going to leave part of the assignment so that you work on that in the afternoon. So let's go and do a quick run through of what the project is about so that you know what to expect. Originally, this has 2 parts. As you can see right there, part 1 due today, and then you have a part 2 due Tuesday. These rules are still going to apply, okay? You still have 2 days to finish the project. So on the first part, the idea is you're going to set up a register and login endpoint using SQLite. This is going to store user information, and we're going to make sure that the password is not stored as plain text, because that would be bad. And then for tomorrow, we hope that you're going to take that, build upon it, and then use sessions and cookies to keep the users logged into the system, into the API across separate requests. I wish I could do that on Friday, but we can't. We're now doing more things. We're last week we're doing some extra stuff now with graduates. So we're going to be devoting having one-on-one meetings and coaching. You're going to benefit from that. That's a new initiative that started this week today. So we're going to get assigned a set of students. We're going to be doing one-on-one coaching and in groups with them. So time for the instructors are going to be, yeah, we're going to have quite a few hours devoted to coaching one-on-one and groups. So those extra lectures and any extra time that we didn't have, we no longer have. All right. So instructions. You will build the solution from scratch, fork and clone, work on that. And we're going to have a few endpoints. This is part of the regular authentication workflow, when you have a way to register by saving a user to the database, and then a way to log in, and then a way to protect. The whole idea of authentication is so that you can protect some endpoints. So we will have a third endpoint, and the idea is this endpoint is going to return a list of the users in the database, but only when the user is logged in. If they're not logged in, they're going to get bounced with a message say you're not authenticated. Oh, a question there of the one-on-ones. No, that's totally different. This is after you graduate, as you go into your labs and the process of finding a job, you're no longer going through lectures. You're now just going through the process of looking for a job. You will be meeting with instructors in 2 settings, right? You will be meeting one-on-one, that is only you and the instructor, but there's also going to be settings where you have a group of students working with the instructor. Maybe we're looking for that number, 7 or 8 students on a group, but this is, you're not going to be long. This is when you graduate from school already. So this is not going to affect you for now. You're still working through the content. So you have your time filled up with that. But the idea is after you graduate, even if you're not forced to be in those groups, we recommend that you do and take advantage of that so that you continue getting better while you're looking for a job. because the process of interviews is not, companies are not just waiting for applications. So the process of an application, even after they receive and then they're looking for someone, it takes a while between the process beginning and by the time you get interviews and all that. Normally that's the way that it works, and that could take some time. So the idea is we want to keep you kind of uh, on a process of constant practice and growth as you prepare for those interviews. It's a pretty nice idea. Well, means that even after you graduate, you're still getting support, right? Um, Continuously. You do get that from careers, but it was the instructors that were not involved in the process of helping with technical questions and all that. So it's pretty nice. I like it. The thing is that 12, not 12 hours a week. There are some things that I'm gonna have to give. One of those is doing ad hoc. Some extra time that we have to do Zoom meetings and things may shift a little bit. Anyway, so majority rules. No, no, not really. In this case, I'm talking about the votes. If we have one person that is uncomfortable with that, we'd rather just keep the tradition going and then introduce this on the next group. Um, just fair. It wouldn't be unfair for them to be forced into doing this. All right, so let's go through this. So the idea is after you're done with the lecture today, you can have enough to do part of this. And then if we don't get to cover everything, we'll continue working the way that we've done traditionally. So tomorrow you're going to have the rest of the information and you should be able to complete this project. This is a stretch problem. Remember, this is not something that you have to do. We want you to concentrate on finishing the MVP. By the time you do this, you will have a fully functional authentication workflow. So people will be able to register on your site, they will be able to log in, and then you will have a way to protect some routes or some resources saying, if you're not logged in, you don't get access to this. Okay. And we'll show you a way of doing it. There are a couple of ways of persisting that authentication. Sessions and cookies is the first one. So that's it for your project. You just cloned. It's cool because as you work on and following along with me, you're gonna be actually working on your project for the afternoon. So the sessions and cookies is the stuff that you're gonna work on the afternoon by yourself. But in the morning, we're gonna do the endpoints and all that together here. All right. Remember though, there is a questions thread. So if you have questions, I have that open. So ask them there so that I can stop and make sure that I answer all of them. So cloned the repository is a question on Slack. Please let me know if you're still cloning. I finished cloning mine and I opened, remember, yours is going to be different than mine, but the ideas will still apply. I'm trying out this dark theme. Does it goes across well on what I'm looking for is that it's easier to read for everybody. Like the colors, the contrast. If I could get a couple, if I could get someone saying, no, I can't read it, it doesn't. Let me show you some JavaScript. This is what it looks like on JavaScript. Okay. Yeah, that doesn't have to be pretty. The idea is that you can see the code clearly. Cool. All right. Called Night Owl is from Sarah Dreisner. She built this. She's big into accessibility and design. So she built it in such a way, after doing some research about people that have problem with colors, and it was sometimes she does a lot of presentations, and so some people will have a hard time. So she decided to come up with a theme that would have a high contrast, and it seems, I find it strange because I feel like this light blue with a deep blue background would not read well for some people, but apparently she's gotten good feedback. So I want her to try it because I'm suffering from the same thing. I'm doing a presentation. I want to make sure that everybody is getting is able to read the code effectively. All right, you're funny. You're funny. All right, so let's go take a look at some of the theory right behind this. And when I say theory, what I mean is some stuff that we need to understand a little bit. But I'm going to move fast through this because the content is there. So instead of covering the way that I used to cover before, I'm just going to go faster so I can move quickly into the code. Okay, so just have that project open there, ready to go. So a couple of things I want to call your attention. Again, this is going to be here. You can see that we have some bold text. There's a difference between authentication and authorization. Authentication is the process of establishing identity. This is where me, as the API, ask, who are you? Okay? And you have to find a way to establish your identity with me, with the API. And then authorization is different because authorization is, I know who you are. Now I decide what you can do. So in this case, you may be logged in, but you may not be an administrator, so I'm not going to let you go into this particular resource. And that's the difference. One is establishing identity, and the other one establishes what can you do once I know who you are. And that would be authorization. Big difference. That's one of the takeaways for today. So normally, when you're rolling your own, you need to have at least a way to register, log in, log out, and a way, for users to reset their passwords. And there are different ways of doing this. Normally include different services, but the idea of resetting passwords this way is you never, ever, ever should be able to go and have access to a user password. So if you are signed up for a service and you send them an email saying, I would like to get my password back, and they are able to send you your password, please delete your account and don't use that service. No one should ever be able to get your password back. What they should send you instead is a link saying, go here so that you can reset your password. Because password saving should be a one-way process. Never, ever should they be able to get your password back. That would be scary. So, of course, whenever we decide to work and roll our own authentication system, we need to think about security. So there are some considerations that you want to take into account. Some of them are how I'm going to store the password, the strength of the password, limitations that I'm going to see when you go to some website, they say, oh, you have to give me at least 8 characters and at least have to have, a uppercase letter, a number, and a special character. Otherwise, the password is not valid. And also some kind of safeguarding against brute force. Okay. So some of those things are already solved by external libraries. We don't have to come up with solutions for them. The mathematicians and the people that have been doing this for a long time, they have already come up with solutions. What we are going to learn is how can we implement those solutions and take advantage of that knowledge into our system. So the first question is, how do we store passwords? And the two that come to mind immediately are hashing and encryption. Short answer is hashing. Because encryption is a two-way medium where you can encrypt something and get it back. We don't want that. When it comes to password, you want hashing because hashing is a one-way. The way that it works is not important. You could see some notes in here, right? I used to explain that, but I understand that there's less value on me just regurgitating what's there on Training Kit. Just give it a read and read a little more if this is something that fascinates you. But what's important, the takeaway is we're going to do hashing because it's a one-way process. You get a password on plain text, you pass it through a hashing function, and then you get a hashed password on the other side. Again, we're going to use a library for this. So what about password strength? Well, there's this place right here where you could go and check how effective are some rules when it comes to passwords. Like if I have the word pass, how long would it take for an attacker to generate a list of all possible passwords and find that in that list? And it would take really nothing, right? So if you go, that link is on Training Kit, right? It says this website. If you click on that, it will take you to this, and then play around with that. But the idea is the longer the password is, the harder to crack. So it's not only about complexity. So the preference is, and this is a personal choice based on a lot of articles that I read, I'd rather go with a really long password, and not necessarily like this, mating words, because if they do a dictionary attack where they look for words in the dictionary, this is actually 1, 2, 3, so they look like characters now. But you do things weird like that. Maybe the first time you do a dot, and then you do a dash, and then you do a dot, and this is a pattern that only you know about. You're gonna come up one. Maybe you use percentages. Maybe you use another characters. Maybe you stick a letter in there. But the idea is that maybe you do commas and then dots and then this. But come up with a pattern that only you know, because that will break or slow down dictionary attacks. Okay, because now this is not a word. It looks like a single word going to beginning to end. Okay. But the idea is this is going to take about 2.67 million trillion centuries in order for them to do a cracking of this password using a massive cracking array, like, you know, thousands of really powerful computers just having at your password. This doesn't mean that they're hitting your API this many times. That means that they're trying to pre-generate all possible combination of letters into a database, and then hashing those and looking at the hash. Because the idea is, remember, we said we're going to use hashing for our password. We're going to take the plain text and we're going to generate a long string from that, okay? And that long string is going to be unique per password, which means that it behaves like a pure function. Given the same inputs, like password and the options that you pass to that function, you always get the same hash. And it has to be that way, because how can you check when someone tries to log in later? The way that you check is you take their credentials again, you run it to the same hashing algorithm that you used to save the password, and then you compare the two hashes. So what attackers have done is say, okay, so let's say that they get into a database, into a company, and they get access to the hashed passwords. They don't have your password, but they have the hash. So the idea is they create what is called a rainbow table. And what they do is they take all possible combinations of characters and different hashing algorithms with different options, and they pre-generate hashes for those. And if your password happened to be one of the hashes that they already pre-generated, they could just do a search and say, hey, give me the password where this hash is the value. And they could get your password back. And why is that bad? Well, because people tend to use the same password on different sites. So it may be that you have some membership to some forum to talk about, ceramics and building kites, and then you have the same password for your bank account or your email. So if they get into that website that didn't really care about security, so they got into their database and they stole your password from there, now they have a way, if they could somehow find that hash into their database, they have your password, and they could try that in your banking account now. So dealing with user password is a dangerous proposition. So you want to avoid it if you can, but if you cannot, this is the way. You want to tell users, and you want to kind of nudge them in the right direction by saying, 8 characters is not enough. Trust me, it is not. So if you go with 8 characters, I don't care if you put, percentages, and you put uppercase, and then you stick number 1, number 3 in there. I don't care. Look, with 8 characters, and a lot of banking institutions will ask that you have 8 characters with at least 1 uppercase, at least 1 number, and at least 1 special character. Look how long it takes. So if they're producing, and this is assuming that is one person trying to do that and have their own database. This doesn't remember that they have been doing this for decades now, for years, right? So they have been accumulating all of those. So if you divide that work among a series of people and say, I'm gonna attack words, with only 3 letters or only 8 letters with one hashing algorithm, and then someone else works on another subset of letters, like I'm gonna tackle combinations of the first 20 letters up to 8 characters long. This is my job, so I'm gonna work on those. And then someone else takes the rest of the letters up to 8 characters, but they don't have to come up with the first one. So they just divided the work. Now imagine that they divide that amongst hundreds or thousands of crackers all over the world that collaborate on this thing. So that 1.12 minutes just turn into milliseconds again, right? Because they're not dealing with the whole set. They don't have to go through all the characters. They're just doing a little piece at a time in parallel in different places. And they have been doing this for years and dumping those into databases that they have, right? So this is not good enough. You want trillions of trillions of trillions of years. So 8 characters, no matter how difficult it is, not enough. That's the walk away. If you only walk away with this, and you ask me this week, if all you want to, if you, what can I take away from this week? Well, 2 things. You need to go and update your password. You need to have a separate password for everything. And if you're not paying, one of those, I pay a service. It's like $60 a year, I think. Pay a little more because I pay for my whole family, so it's like $99 a year for my whole family. But if you want to pay individually, it's like $50 or $60 a year. Buy one of those services, okay? Don't use one of the free ones either because you don't know who they are. Buy from the like LastPass or OnePassword is the one that I use. You can see it right there. So buy one of those services so that could generate long, really long pass, as long as they will let you on any website. It kind of angers me a little bit when I go to a place and they say, oh, 20 characters is enough. No, it's not. No, it's not. So if you go to a service that is something that is delicate like a bank and they want to have you and they limit that you can only have 12 characters long passwords, maybe you should change banking institutions, okay? This is not a good idea. 12 characters is not enough. If you see me type, my daughter smiles here because when she sees me typing the password, my master password here, this has got to be like 70 letters long. It's like really, because this is the keys to the kingdom. Same thing happens with my email. What happens with email? Well, when you want to reset your password, what do? Send it to my email. So the email should have a password that no one in the world will ever, it's got to be really long and complicated. So I have one generator that is really long and complicated. I will never remember that. I remember this one because what's the beautiful thing about this? Since we're talking that length is more important, you could take your favorite poem that you ever read from French poetry that has a little piece of that poem that only you know about that, right? That they would never know. This is something that is, you would never told anyone. This is something that is unique to you. And it's really long. So it's going to be hard. And if it's in a different language and you're an American English speaking person and you write that in, I don't know, Greek or something, they did not expect that. They're probably going to hate trying to guess your password using an American dictionary, an English dictionary. So make it hard. So that's the first one. And the second one is don't roll your own. Don't store users' password because it's a big responsibility. Okay? And if you do, respect those rules. Like ask them, please, minimum length is going to be 16 characters here. I'm sorry, is that a problem? Well, here's some suggestions. Find a big phrase or something and give them that. Help you users generate good passwords. That's it. That's the week. The rest is just technology that you can learn in tutorials. So let me go back and see where we are on questions. So don't most websites lock you out after a few attempts? Yes, and this is why I'm saying this is something that they're doing offline. They're just regenerating. This is a really good question. This is what I mean when I say that doesn't mean they're hitting your API and trying to connect. They're just regenerating hashes so that they can, if they steal your password hash, and that happens more times than you think every day. There's a website called Have I been pawned by Troy Hunt? You want to follow Troy Hunt? Because he will tweet about, sometimes many times a day, about password breaches. So if you go and look for Have I Been, oh, this is an article. This is not really the website, but they're probably going to have a link to that website. And if you sign up for it with the emails that you normally use, he's going to send you back an email, and he's a trusted source on the security. So like, at least I trust him. So he's a really trusted source in the security community. He's going to send you back an email saying your password was breached in this attack, this attack, this attack, and this other attack. So he's going to tell you how many times your password was stolen because they went. Let's say that you have you know, a password that you use on T-Mobile. So whenever T-Mobile was hacked, people got into the databases and they stole your email, and they had access to your hash passwords. Oh, wait, no, that did not happen. You know why? Because T-Mobile, up to a few months ago, was storing users' password as plain text in some of their subsidiaries. They said not in the United States locally, but it came to the public attention that they were storing users' password in some of their databases as plain text. Yes. So if you happen to be a customer in one of those databases, that means that whoever broke into T-Mobile got your password, and if you're using the same password in other places, they could potentially get into those places. So yeah, go change your T-Mobile password. They say that that's not the case in the United States, so we might be safe. I'm a T-Mobile user. Anyways, so that's related to the brute force attack mitigation. So how can we protect against that? Locally, and this is an explanation about the rainbow tables. Locally, we're going to use a library that already has that built in. So we're going to work with something called bcrypt. And bcrypt is based on a really strong algorithm for hashing, right? And they take the hashing algorithm, they put some options that you could pass in, and then at the end you get a hash that has a way to mitigate generation of that by slowing down the production of hashes. So if the way that the hacker is going to attack or trying to break that is, I have the hash, so all I need to do is pre-generate some hashes based on combination of letters. If we can have our hash, the algorithm that we use require that the algorithm is run many times, like thousands and hundreds of thousands of times. So the idea is you're going to take a password and then run it through the function once. You're going to get a hash, and then you take that hash and you run it to the function again, and you're going to get a different hash. Now, not based on the password, but on the hash. And then you run that again and again and again, and you do that, a few 100,000 times. What you end up with a hash that's really far from the original password. So that process is going to take some extra time. So now, if they were able to generate, 60, let's say that it took a second originally, 60 hashes a minute. If you do that and it's going to take them a minute or two to generate a hash, now you're slowing them down significantly. Of course, it's not about seconds. It's probably about milliseconds more. But that's the idea behind that. You could read more about that. What's important is how do we use this stuff? And the message here is, if you are going to store user passwords, you want to hash them. And that's the first step that we're going to write some code for. Questions on the question step say, when hashing passwords on the front end be a bad practice? Yes. Anything related to authentication or things that you want to keep secret should not be on the client, because hashing requires an extra piece of information, right? It requires the original password. And one of the things that it's got to have is something that is secret. Because that's how the server guarantees that you're not going to send me some hash generated by someone else. So as we add this, you'll see that we have a few things here that we pass to the hashing algorithm, and including we need to protect that information by passing other things like someone mentioned what is called a salt, which is something that you could even generate dynamically. But luckily, the library that we're going to use, they generate salts for you dynamically, which is they take your password and another random string and add it on top of that. So it's not only hashing your password, they're hashing your password plus that extra salt. And then you need to have some secrets in order to handle that. So, yeah, bad idea. Never do it on the client. So are these companies that are breached using their own role auth solution? Yes, yes. Um, either that or they're using a library, but they're doing the process of authentication themselves. It's not about rolling your own, it's about doing the authentication yourself. So what we are recommending, and this is what every expert in the industry is going to tell you, is if you can avoid it, the process of establishing identity, you want to delegate that to some other company that is specializes in that. And they had a bigger team of engineers that know more about security than the average developer. Even if you're a senior developer, but if you're not a specialist when it comes to, cryptography and security, you're not an expert at that. So the big companies like Facebook or Google, you can bet, and Microsoft, you can bet that they have people that are specialists dealing with security. So if we can somehow take advantage of those Google engineers and have them deal with the passwords and storing and worrying about hacks and all that, I sleep better at night. And then once they deal with that, all I need to know is, okay, I trust that Google is doing the thing right, and it's going to give me confirmation of your identity. And then I only need to worry about what I'm going to give you access to. So you always have to worry about the authorization on your end, but the authentication is the part that we want to have someone else deal with passwords and all this. Now, you might still be required to do this. So let's take a quick look and see what library can we use on the Node ecosystem. There are libraries for every backend technology in order to make sure that our passwords, if we decide to save them, that they are not on plain text. And there is a website, there's a link there on Training Kit. It's called Plain Text Offenders. And if you refresh this, you'll see, oh, this is from October 15. Forgot password, right? So this is funny. They will sign up with an account and say, hey, can I get my password back? And then they get an email say, hey, yes, your account details, your username and password. Bathrooms administrator, you guys. That means that they're saving the password in a way that they can get it back. That's bad, right? So, and this is where Game, I don't know what that is, but 2game.com also has the same problem. Xhamster, source, whatever that is. Eco Carton, STEM graduates. So there's a list of companies that all suffer from that. That's really bad. There are a lot of them. So plaintextoffenders.com has on Training Kit. Go play around and see if your company appears there. So some other links that you'll find there before we start writing some code is, and this is for you to read later, Xhamster, yeah, it's kind of funny. It's called OWASP, Open Web, man, I forget, Application Security Project. Yes, yeah. So the Open Web Application Security Project, they publish every year something called the top 10. And what they do is they study this stuff. And they tell you, these are the top 10 risks that we have discovered companies suffer from the most during the year. So I don't think they have published the 2018 yet, but the 2017, they ranked them. And you could click on that and they give you even more information. Like, for instance, injection. You remember that we mentioned SQL injection, right? And I say, when you use Kinect raw, pass your parameters instead of just concatenating in a string, because that makes you vulnerable to that, right? So if you click on that injection, there are different types of injections. And then you get like little more details about how that works, security weaknesses, some example attack scenarios like this, right? Like you're concatenating in a string like that. Bad, don't do that. Luckily, Kinet will give you a way for you to pass parameters there that is safe and connects the library. Will take care of escaping that and make sure that you're not vulnerable to this attack. So use that instead of concatenating this way. And they have even more references about that. So parameterized queries is the way that Connects does it, but there are other types of injection attacks, and they give you recommendations for those. If security is something that interesting, you always want to keep an eye on what is it that could possibly be a problem in my application, and you go down that list. So broken authentication, of course, functions related to authentication and session management implemented correctly. Why? Because you have developers that they're really good front end or back end developers, but they're not security experts. But yet they decide to go and implement their own. So if they do that process wrong, probably if I had to do it, I would probably do it wrong because I don't know everything about security. Like password keys or session tokens and some kind of other things that they do broken authentication is number 2. So yeah, it's dangerous. Sensitive data exposure. So go and take a quick look at that. Just do a search on, actually, let me just give you that link just in case it's not there. But this is something interesting that you want to read if you ever decide to, go secure by default, and you should, your API. Security misconfiguration, cross-site scripting attacks, insecure deserialization. All of those are risks, valid risks that are out there. Third takeaway, be afraid. Always be afraid. People are coming out to get you, okay? They want to get at your API. Oh man, Drew, one time he called a customer service line to get a password reset, and they gave him his password over the phone, probably on one of those. We're going to record this conversation for security assurance purposes. So anybody else that had access to that recording also have your password, man. That's not good. All right. This link is also training kit. Best practices for user account from the people at Google. So I kind of trust them a little bit when it comes to this, right? So they say, look at number 1, hash those passwords, right? And then you move, allow third-party identity providers if possible. That's the second one, right? If you have to do it, hash them. But if you have to, don't. And they say, well, you can use Firebase Auth from Google, of course, and there are others. Separate the concept of user identity and user account, right? This is different. The account is one thing and the identity is another. And they give you a little more details on how that, like some ideas. Multiple identities to link to a single account. So you may have Google sign in, Facebook sign in, GitHub sign in, all linked to one single account. Look at this. Don't block long or complex password. Don't tell me that 16 characters or 12, between 8 and 12. No. If you want to have 65 letters with a combination of different characters, yes, we support that. Don't impose unreasonable rules for usernames. Oh yeah, that's a big one. I would say the same thing for passwords. Okay, if you want to have usernames that are long with spaces, yeah, we support that. And there's no reason why we can't do a search on a string field on the database. It has to be something without spaces. I don't understand that. Not in this day and age, right? They should be able to change the username. What if you think for some reasons, for some particular reason, you think that maybe your username was breached? You want to change that? Yeah, you should be able to do it. And you could do that, right? Because your account doesn't really depend on the username. It should depend on a unique ID that references your account and nobody knows about it on the database. But the username is just another property that you should be able to change, right? Let users delete their accounts, conscious decision of session length. And when we talk about session management, we understand what that means. And two-step verification, of course. You could get that with some of those like Firebase Auth. You could do like SMS verifications. So two-step multi-factor authentication. And of course, you have devices that you can use for that, like extra keys or they generate keys every few seconds. and they will ask you, hey, yeah, I know you have your username and password. So it's the idea of something that you know and something that you have. Now, show me that it's you, not only because you know your username and password, but because you also have the mobile device and maybe you have this other key that you can use. There are different ones. Casing sensitive IDs, secure auth system, and then they give you ideas like the idea of password resets instead of password retrieval, right? And they give you more. So continue reading. They have links in there. It's a really interesting read for security purposes, right? Questions? Okay. So let's go and add some code. Since everybody has this ready, we need a few things. We're gonna first implement the register endpoint, and there's some code here. We're probably just gonna come and copy that. But the idea is we're gonna bring in a library called bcrypt.js. Bcrypt.js is this library right here. There are a couple, right? You have bcrypt.js, you have bcrypt. We select this. It's got about 500,000 downloads daily. Um, the other one is good too. So we have to pick one. We pick this one, right? Bcrypt.js. So we need to install that. So let's go back to write some code together. I'm going to write it. I'm going to give you time to write it, like always. So we have this package.json. Let's see what we have already here. So we have course, express, connect, SQLite3, and there is no bcrypt anywhere. So let's go and install that. So yarn add bcrypt.js should show up in my dependencies. Express. Let me update this to the latest. What? Oh, typo. It's bcrypt.js. All right. So once that's done, we're going to require that. As always, for demo purposes, right? We're going to be working on index.js for demo purposes. These are things that you would probably have somewhere else. Oh man, this is taking a long time to get this. I'll let it do its thing. All right. So I'm going to do yarn also. Oh, not here. Not here. Not here. Here. I'm going to do yarn down here. This is just to make sure that I download all the other packages that I had on package.json. All right. Like Express and all that. All right. So that's ready to go. And then in the package.json, we already have for you set up a script down here called start. So we're going to do that. We're going to run this. So yarn start. We'll start the server. It's running on port 3300. All right, so it's getting here. Let's try it out. Let's make sure that this is actually running, right? So let's go and hit this on 3300. Why is my computer so slow? This is, I haven't even updated. Something else that I'm running that is heavy. Okay, let's try it. Let's try it again. So 3300, send, and it should be alive, right? It's alive. So I know that my server is running. Let's clear this up. And it's alive. All right. Remember, you'll have time. So the idea here is we want to have a way for you users to register with our system. So let's start by implementing the register. So the question is, it says, auth mini repo. No, I told you, I sent that link and I said you're going to be working on auth 1. Yeah. Yeah, you're going to work on that way ahead. I am way ahead, but you're going to have time to go and implement it. Cool. So far, this has endpoints and the database stuff. Not yet. It's the same way every day, right? I'm going to show you something. You're going to ask questions, and then you're going to start working on that. The idea is that we do an hour of work together in the morning, so you could get some of the project for the afternoon done. And then I'm going to introduce a concept and probably going through the video because you're not going to follow along with that second part. Instead of following along with me, what you'll do is go and implement it in the project in the afternoon, which is the session portion of it. So for now, all you need is an Express server, as simple as you can make it, that is going to have a register endpoint. Okay. Let me build it first, and then you go from there. So we're going to use bcrypt in this file because we want to hash the password. So the idea is I'm going to build a post endpoint here, post route. I'm going to have to restart my computer. It's crazy. All right, so slash, let's call it register. Homies. And here, we want to grab the password, right? So const credentials equals rec.body. We're going to assume that we're going to get that username and password sent as part of the credentials. Why username and password? Well, I believe, let me make sure, because I thought that the password, the repository had already the migrations. Maybe I'm remembering this incorrectly. If that's the case, I think you're gonna have to do the meeting with me instead. Oh yeah, it's really empty. That's what she means. Yep. Nope. All right. Somehow in my mind, this has the data. This had the database already there. So this is not going to work. Let's do this project and let's grab and use the guided demo project, which is this. So clone this. You don't have to fork it, just clone it instead. Yeah, makes sense because this was designed to be a 2-day project, so you had some work to do, like setting up the databases and all that as a way to practice more. So you'll do that. All right, let's do that. Okay, so I'm gonna give you a minute to go and clone that mini instead before we proceed. Michelle to the rescue. Thank you, Michelle. So while you're cloning that, the idea is you already have the migrations here, and you already have a small database in there, so you don't even have to run the migrations. It's already there. And this has a username and a password, right? So testing our endpoint, we're going to assume that those credentials are already there. Let's call it credentials. Okay, so we have still one person cloning the mini. You will follow along after we do the explanation the same way that we do all the time. So the question is, do we follow along now? No, because then you're not going to be paying attention. So let me write it, and then you build it. All right, looks like everybody else already downloaded. So use the command that you normally use to add packages, node packages. If you use npm, you're going to use npm. If not, you're going to use yarn. If you're more comfortable with npm, just use that. Npm install and then the name of the package, and then it will install it as a dependency on your system. Okay? All right. So I'm pretty sure after 2 weeks of Node, you're pretty comfortable installing packages one way or another, either yarn or npm. So I'll write the body for the credentials so that I'm going to assume that they're going to send me a username and password, right? So we have those. The idea is that we want to save that user to the database, but not with the password that they send us, but we want to hash that password. So we're going to bring in bcrypt up here. Okay, so I'm going to separate this line and say, even though it's just another package like any other package, right? So rem, let me see if this works now. Yep. So bcrypt, it's going to be bcrypt, but not bcrypt, but bcrypt.js. There is a bcrypt package, so either one will work. I found out bcrypt was giving some users problems with the latest version of Node a few months back. So I moved to bcrypt.js because that hasn't run into any issues for me so far. All right. So here we want to hash the password, then save the user. Okay. So how can we do that? Well, in the case of bcrypt, you need to pass a couple of configuration options. We're going to have them in here, and then we'll see if we need to extract them out somewhere else once we do that. But the idea is that you're going to generate a hash first. So you're going to say const hash, and this is going to be a call to bcrypt. Bcrypt has a couple. If you go check the documentation, you could do this synchronously or asynchronously, but either way, you're going to have to wait until hash does it. I mean, bcrypt does its thing, so I just use the sync out of the box and say, I'm going to pass the credentials password. That's the first argument that I pass to that. And then the second argument, since you could either pass a salt, like a random string that you generate yourself, or the library can generate one. So I just let the library do that. So the next argument would be, how many rounds do you want me to go through? How many times do you want me to hash and rehash and rehash and rehash to slow down attackers? A good number should be starting somewhere at 12. So the idea is, if you can stomach the time that it takes to do something like 14, start there at least 14. So this number is not doing it 14 times, it's going to be doing it 2 to the 14 times. So it's a big number, okay? And you're going to see that it slows down a little bit by trying to generate that. So at the end of this process, you're going to get a hash. So the next part is, okay, once I have the hash, now I'm going to take the user. So the credentials is representing now my users. I'm going to say credentials, that password, and I'm going to override that with my hash. So now the credentials has the username and a hash. The password is going to be the hash. And now we're going to save the user. So here we have this DB, right? We're going to say DB. Going to the users table, and then insert, you pass the credentials. To create a user based on that, then you should get a user back in theory. Actually, in this case, I think because we're hitting it directly, so it's going to be the set of IDs. We're not using a little library that returns the user. Const ID equal to IDs, just to make it clear that, you know, it's an array, and you grab the first ID and you return that if you want. So res.status 201 because we're creating, and then just send back the new user ID and then send the ID. This is just to have something that we send. And then the bro, right? The other bro. If we have an error, we want to know about that. So rest status for now, just that we can inspect it on the client if we run into an error to see what's going on. And then we send that error down. Now, you saw me doing step by step. We install the library using yarn add or npm install. And then we wrote down an endpoint. We grab the credentials from the body, the username and password. We hash it by calling bcrypt hash sync, passing the current password and a number of how many rounds do we want. That we want to start at least at 12, but 14 is a good number. And then once we have the hash, we replace the password that we had on the credentials with the new hash. So we no longer have access to the password here. And then we go and insert into the users table, passing those credentials, that username and password, and then the rest is what we've seen so far. If that works, the idea is that if that works, we should be able to get the users. So this is an endpoint that is already here. It will let me get the users. I'm only bringing the ID, the username, but just to see how that works, we're going to also bring the password back from there. And we're going to return that. I'm going to save this, making sure that we didn't break anything. And then we're going to go back. Before you start doing it, you're gonna hit it in a minute. I'm gonna go to users. Shouldn't be anything in there, right? Because we haven't created any users yet. Is it API users? Yep, it's API user. I'm just gonna change this to users just to make it shorter. All right, so there are no users, but going here, duplicating this tab. I'm going to restart in the break. I'm going to close them all. Let's see. All right. So let's try this. Register. Make it a post. Pass in a username. Tom. Send a password. Let's make it unique for everyone. Password. So username and password. Send that. And hopefully, after a long delay, we get the new user ID would be number 1. You see how long it took? This is because it was generating the hash. So now if we duplicate this and go back into the users with a get, we should have a user in there. There you go. And look at the password, right? This rambling generating hash, and we cannot get that back. So it's working. Your turn to go and implement that. And then after that, we're going to take a break, then come back and talk a little bit about sessions and how those work. So we do our hashing function as a middleware. Yeah, you could. Just make sure that middleware is going to be used locally on whatever you want to do the hashing. You could. Normally, the hashing is going to happen in 2 places, right? And when you're doing the login, you want to have a middleware probably to check for protected resource. We're going to get to that stage later. But the idea is, in this case, you keep it simple. For now, we're going to be doing it on the register right there, because this is the only place we're going to use it now. So let me get rid of this and this, so make sure that you can see the whole thing, right? So on the user's endpoint, the only thing that I did was selecting the password field so that you could see that it was hashed. But then, other than that, we added this line, right? And then we implemented this. Go have at it. You don't increase your hash passwords on the front end ever. This is going to happen on the back end. On the front end, you're going to capture the username and password and just send it back. Tom's password has been exposed. In answering to Mike, but I think my microphone was muted. So, yep. I scrolled down and I said, remember to add the password here, but you should never do this in production, right? In production, you're supposed to be returning everything but the password. But he figured it out. I'm sorry, Michael. Yeah, that was me answering his question, why he wasn't getting the password. All right, so I see that just about everybody that answered that poll on Slack is ready to go. So let's go take a break. Let's be back in about 5 minutes. Let me see if I could keep the code on screen because there's a lot of code to type. So just in case you're not quite done yet. At the same time that we also show the clock underneath. Let's see if that works. Here we go. See you in 5. The motivation to go and reset your passwords and making really, really hard, we won. So a good question out there, what is a salt? Salt would be, let's say, I'm going to fake one here. I'm going to say const salt, right? And it would be just some kind of randomly generated string that will be concatenated with the password so that when you generate the hash, it's not only the password anymore, it's the password and the salt combined as a longer string. And then that's what's going to get hashed. The beautiful thing about this library is that you don't have to worry about this, okay? They will generate one on the spot for you when you call that hash sync, and they will know what it is. It's part of the hash, so they're able through the library to get that salt back when verifying your passwords. So yeah, pretty cool stuff for free. We get out of the box. All right, so let's go back and do it again. Hopefully my microphone was not muted then. So the password, it's here on that get. You just add it here. I see the other answers were password were taken care by the community. Thank you, Vera and Tom. So I'm still unclear what hash does. It takes a plain text password and it gives you back a hash of that password. All you have to give it is the password and a number that will represent how many times. Remember, this is a number that's 2 to the 14, but what it means is you start somewhere at 12, and what this is going to do is just going to hash and rehash and rehash and rehash and rehash many times. This is how you slow down attackers. The higher the number, the slower the hashing algorithm works. So you saw how when we saved, let me show you the difference between 1 and 2. So let's go and create another user here. This is going to be for Sai. Okay, and if we go and save Mississippi 1, Mississippi 2, Mississippi 3, Mississippi 4, right? It takes a while to generate that. So let's go and make a quick change here and say, I don't know, 8. That was 14. I'm going to make it 10. Only 4. You'll see the difference between 14 and 10 is significant. So the higher the number that you can get away with the user, the better. So let's go and grab now Jonathan. Mississippi 1, not even Mississippi 2, right? The difference between 10 and 14 is significant. So that means that the lower the number, the more hashes they can pre-generate from your algorithm. So make it as high as you can without bothering the user or having the user wait too long for it. Again, 14 seems to be a good number because people is used to when they create a password, we show them something on the UI, they're used that to waiting a little bit while registering for our website. Same with logging in. And this is just going to happen on login and whenever they access something that's protected. So that's the hash. Take a plain text password and give you back the hash. So you save the hash to the database instead of the password. Cool. All right. So now let's do login. Okay, we're back. So this case is going to be login. Again, we're still going to get the credentials, right? So the credentials, I'm going to call it creds now, just type less. They're going to come from the rec.body. They're going to send us that. And then we're going to say, hey, DB, get me the users table. And I'd like to see if this user actually exists. So I'm going to say where, pass in the username. And this is going to come from creds.username. Now, what should we get back? Well, hopefully a collection of users, right? To make it, like, so that we don't have to deal with the array coming back, we're going to assume that the username is going to be unique. Probably should be unique. So we're going to call first here to say I'm going to get only one back. So if this returns something, it's going to return the user or not. So once I have the user, what do I want to check? Well, I know by the time we're here that I went to the database and one of two things happened. Either we got the user or not, so I could check if I have the user. We're going to check for something else in a minute. If I don't have the user, then that means that the user doesn't exist by that username. But we don't want to return that message to an attacker. We don't want to tell an attacker, notify the attacker that the username is not valid. We want to always treat that as a failure on the authentication. So in that case, if I did not find the user by that username, I'm just going to say red status. I'm going to say 401. Yep, you're not authenticated. JSON message. Right? Because I didn't find the user for that username. You're giving me wrong credentials. But let's say that I found it. So in here, I found the users. I found the user, but I don't know whether they gave me the right password or not. So there is a function that you could call on bcrypt called compare sync. So I'm going to say, I not only want to have found the user, also I'm going to call bcrypt right here, just to save, and call compare sync, passing in the credentials password that you gave me. And since I am here already, I found the user, so I have access to the user from the database, including the hash, right? So I'm going to say, compare that to the user password. That's the key right there. This. So by having them combined there in the user, I save some code, right? And instead of having that outside, calculate and then check for the well. So the idea is if that is true, if I found the user with that username and this returns true, bcrypt compares both passwords, the one that I gave me and the one on the database, and the hash are the same, then I know that the credentials were correct. So in that case, I'm just going to do something, right? In this case, I'm just going to send something back for now. And then the other row, if I run into some kind of error there, just send back the error, save some typing so that you can move on to work on this quickly. So like that, okay? That's the basic logic of it. You could do a lot more, like validate, make sure that you have a username, that you do have a password and all that. But that's the basics of it. Once you do all of that extra thing that's not related to authentication, the authentication portion of that is checking, comparing the passwords. And Bcrypt knows what to do for that, so you don't have to worry about it. So try it out. So we have Jonathan here. Instead of going to login, to register, we're going to go to login and hit send. Oh, we got an error. Oh, interesting. Let me see what the error is. Maybe we have something here where first and user. Let's go check out terminal, see if we have an error. Oh, no errors on the terminal. That's interesting. Why did we get that error? Rest that line 42. Oh, rest. Do it on the rest. Rest that status. There you go. Do it on the rack. Good eye, good eye. All right, welcome Jonathan, right? What if I say Jonathan's, send that, it's gonna tell me you shall not pass, but it's not gonna tell me why, because that way I will never reveal that all you have to do is try to find the password now. And then send, you shall not pass, but you don't know, is it the password that's bad? Is it the username? Nope, you don't know. The point is that you only allowed when you provide the correct credentials. Your turn to go and implement this simple login. Do I always use a post for logins? Yes. And the reason for that is because you don't want to send login information as part of the URL. People can see that. So you need to send it in the body. Drew, thanks for checking out that typo there. Makes sense, Clint? Why always use a post? Okay, a couple of questions there. What is compare sync doing? Is checking, is comparing two passwords. It's taking the password that comes as part of the credentials on the body against the password that you have on the database. You're sending a password in plain text, is hashing it again, taking the hash and comparing it to the one on the database. This is going to tell you whether they match or not. And then how do I test it with Postman? Oh, I'm just doing a post to the URL, and then I'm passing username and password, and changing the username to something that is invalid, that I know it doesn't exist in the database, should give you the you shall not pass. And also passing the wrong password should give you you shall not pass. And passing the correct credentials should tell you welcome with the name, with the username. Just make sure that it's a post, right? To the login, the body on raw, and you have JSON here instead of text, so that this valid JSON goes across. Probably an error in the code. Make sure that I had an error here that said, rec instead of res. I don't know if you fix that. On this. So if you use BigCrypt for a website with many users, what am I looking at for security? Professional and good? Well, at least you're looking better than T-Mobile, for sure. No, this is a good first step. Remember when those 12 steps recommended by Google? The first one was hash the password. So you're going in the right direction. If you use, doesn't have to be BigCrypt. You can use something called Crypto that is built into Node.js too. So any respected, uh, it's called a key derivation function if we want to get technical. But the idea is something that hashes the password and that will generate random salts, and that could do many rounds of the generations to slow down attackers. It's good. BigCrypt just so happened to be one of BigCrypt or BigCrypt.js or Crypto happened to be in the Node community very well respected. So yeah, you're looking good. It's a good start. All right, Michelle. Let me give you this, because at this point, what's important is that you understand the concepts. Any typo like I had, comma, whatever, may break your code. So I want you to try this to see if this will still give you an error before continue. So I dropped what I have so far as part of the post to login on my end. Please let us know. So as she checks, we have learned so far passwords, the importance of having strong passwords, that we should never store plain text. So we should hash them somehow. And we want to use one of the key derivation libraries that are well accepted in the security community, including something like Crypto or BigCrypt or BigCrypt.js. That we should move away from storing passwords if we can find a different way of doing this. And then you should go and reset your passwords, for sure. Looks like we're not going to move to sessions today because we only have 15 minutes. So let's take those 15 minutes to make sure that we all catch up. Maybe talk about sessions, but we implement them tomorrow together. Michelle, did that work? Are we still getting an error? Huh. Interesting. Is the error that you're getting back just showing error like that, or is it giving you some kind of error? Let's do a screen share. Make sure that we get you all straightened out before we move on. Because this is going to be your reference code for the project this afternoon. What?
Hi, can you see my screen?
Yes.
Yes. Okay, cool. So what I did was I copy pasted what you sent me.
Mm-hmm.
And then I just commented out mine that I did.
Actually, it looks. Yours look good.
And
It's not saved though. Did you save that?
oh my goodness, is that why? I had a very tough morning. It's not. And then localhost 3300 login. No, still.
Yeah, but this is telling us that you cannot post to log in. So there's something with the routing on the server, or the server is not running. One of the two.
Oh,
because the error says that you cannot post to that endpoint. So let's go check out the routing.
The server's running.
Localhost 3300 / login. Show me the console there. Again, it's not giving us any errors.
No.
No, okay, let's go back to the code.
Scroll down below your commented code.
Oh yeah, where is that? Do you have one post inside of another? Yeah, you have to separate those. You have that post endpoint inside of the register.
Oh my goodness! Oh my god! How embarrassing! I'm sorry.
No.
Oh my goodness!
Why is that embarrassing?
Okay. Because. Okay. So, oh my gosh. Okay, no, it's been a bad morning. What did I do? Oh no.
So cut all the code that you have between line 19 and the end of that method. Just cut that out and place it beginning on line 15 or something, so that is outside of the register. That's it. That should probably fix it.
Copy all of this.
Yeah, cut it out. Don't copy it. Yeah, just the whole thing. There you go. Next line probably.
Sorry.
You needed the next line, but it's fine. We pick it up now in a minute. Just place
it here?
Yep.
Or, yeah, let's just put it under. Okay. Now I need a closing.
No, let's do a better one. I'm gonna give you both the register and the login, and then just delete everything you have and just replace it with this, because it's the same code anyways.
Okay.
Because that way, because solving the nesting is gonna be harder than just copying and pasting. And we want to make sure that you can run them and that they work for you, because again, this is going to be your reference code for the project this afternoon. This is why I didn't want to move on until you had it. So it's on, should be on Slack now.
It's been one of those mornings.
You probably want to delete.
Whoops. No, there's a mistake. So I took register.
Log in. Yeah, keep going. You probably want to delete those. Line 51, 52, and 53.
This one?
Yeah, you want to delete all of that all the way to line 64. Yep. There you go. Let's save that. And make sure that it's running. Check out the terminal. Make sure that we don't have any typos or errors in there. Okay, it's good. So let's go try it out now.
Okay, so we have to try.
Oh, you know Jonathan's password too?
I just copied what you were doing.
Try to do a login. If that worked, if the registration already worked, oh, you're doing it anyway. Okay, cool.
I just want to make sure everything works. It'll be really quick. Okay, so that.
Yep.
And let's do Jonathan's. It shouldn't. Yeah. Okay. Okay. It works now. I'm sorry.
No. Okay. Now it works. Now we know it works. All right. No problem. You're welcome. All right. Anybody else? Let me exit full screen here. Bring my Zoom stuff down just because it gets in the way of everything. You see my screen again? Jonathan, you have to go and reset your passwords everywhere now. All right. Cool. So today, again, this is a more of an introduction, get you into a mindset of how important security is, even the simple things that we don't worry about, like when our banking says between 8 and 12, we're like, yeah, this is good enough. I mean, the bank said that's good enough, but not necessarily. So when we design, go take a quick look to those recommendations on Google. Go take a quick look at the OWASP top 10 and read more about security. You're not going to become an expert, but you want to be aware of things that happen out there. Follow Troy Hunt. Troy Hunt is, let's see, Troy Hunt. Follow him on Twitter. Read his articles. He's a well-respected, even he's a Pluralsight author, and he has about. Oh, by the way, you could get if you haven't gotten a free Pluralsight subscription, you could get one. As far as I know, it lasts 3 months. Do you know how to get that? Some people might not. So if you go and do a search on Visual Studio, Dev Essentials. I'm going to drop this link on Slack because Pluralsight has a wealth of courses. I pay for that subscription, but you can start out the first 3 months, I think, for free. So if you go to Visual Microsoft Studio Dev Essentials, you're going to see some of the benefits that they have is training and support materials. So what happens is well, I can't do it anymore because I already have an account. So let me see if I have one here or not. Yep, there you go. Once you make it there, they have some benefits. Use your benefits. It would require that you create a Microsoft account with them if you don't have one, like a Hotmail account or something. But you will see they have quite a few benefits. Some of them these are free anyways, like Visual Studio Community, the Visual Studio for Mac. You could get them for free. You don't have to do that. But you get for a month, if you want to play around with Azure, they give you like $200 for 1 month, the free account on Azure, $200 credit. Okay. Um, what else do they have in there? What you care about is this: free for 3 months, and this is the, I think I paid $300 a year. That's the account that they give you. It's like $300 a year if you buy it. But the first 3 months for free, you do get code, and they're gonna give you a code. Okay, and then you click activate, and you go from there. They have the steps that you have to do for doing that. Also, they have access to the Microsoft Academy and all that. Let me go and mute some of the participants. Yep, they have some other things that you can get out of there. So pretty nice, and it's free. So you get 3 months. So that means that you could go and watch not only the React courses and the courses that you had in Pluralsight about the technologies that you learn here. You can also go and see some of the, oh, look at that, OWASP top 10 application security tricks for ASP.NET. Well, that's ASP.NET. But you could see some of the Troy Hunt's courses on security if you want. Okay, that's it. So your project this afternoon, Authentication 1, go and work on that. Use some of the code that you already have to start implementing your endpoints. And again, remember that for today, if you can get as far as where we got together, that's good enough. What you could do, if you're done early with this, is go into using sessions and cookies and follow through the material here to see if you can figure out how to add express sessions and get it to work. We do have some code in here. So going through the material here should help you out and see if you can start implementing sessions. Here's an example of how to set it up. Some examples of how do you test it. And then down here is actually when you get it to work for the logout. And here, this is how to write a piece of middleware that will check that the user is logged in before going, let's say, into our user's endpoint. So go play around with this, read a little more about, because you have links to the libraries that we're using, like Express Sessions, how to set up this to work. If you go to this link right here, it's going to show you using Connects, like we are. You do a search here for Connects, and you'll see that they have this Connect Session Connects that you could wire up to save your session information inside of the database as well. So this is something that we're going to do together tomorrow, but if you could get a head start, that'd be awesome, because that way you can have better questions for me based on the things that you ran into when trying to implement that. Any more questions for today? Nope. All right. So have a good one, and I'll see you tomorrow.